Alright, so question 1, talking about modelling a sunset of a small island in the Pacific Ocean. So there is our model. So if I just do a little quick sketch of that, we're talking about 6.5 is my baseline up here, and it goes sine. It's not been translated, so it's going to go up like that. And then it's going to go up because the amplitude, it's going to go up to 8.5 and it's going to go down to 4.5. It's just my amplitude and my baseline. What's the time of day, the earliest sunset? Okay, so that's there, isn't it? It's understanding that the lowest value sine can be, which is 3 pi over 2, is -1. If that's the case, S is 2 lots of -1 plus 6.5, which is 4.5. So it's the earliest time of day, 4:30 p.m. What month is the earliest sunset? Alright, well, sort of halfway answered that here, because I need this part here, I need pi t over 6 to be the same as 3 pi over 2, because sine of 3 pi over 2 will give me that answer of will give me the answer of -1. So times that by 6 and divide by pi, so t will be 18 pi over 2 pi, which is 9. So 9 months after September. Okay, so just up here, September is month 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9 months after September, October, November, December, January, February, March, April, May, June. So it's going to be in June. Okay, so question 3, what time is the sunset on December? Well, December up here is actually the 3rd month, so really just what is S when t equals 3? So S equals 2 sine 3 pi over 6, substituting in t is 3, plus 6.5. Now 3 pi over 6 is the same as pi over 2, so that's 2 sine pi over 2 plus 6.5. Now I know sine of pi over 2 is is this 1 value, so that's going to be 2 times 1 plus 6.5, which is 8.5, so therefore it's 8:30 p.m. And so what we do now is find one day in a year where the sun would set at 7:30. So all you're asked to do there is really talk about S is 7.5. What is a T? Okay, so we're going to go 7.5 equals 2 sine pi 6 over, so pi t over 6 plus 6.5. Minus 6.5 off both sides. Let's done that around the wrong way, sorry. That should be pi t over 6. Then we're going to divide by 2, so we're left with half equals sine pi t over 6. And then so now we're going to left with pi t over 6 is the same as shift sine of, or arc sine of a half, which is pi over 6. So therefore what I'm saying is pi t over 6 equals pi over 6, so therefore t must be 1. And so if we're looking for one day in the year, I'm looking for October, or 1 month later, 21st. Okay, so when you're doing these sort of questions, make sure you always start with some sort of basic sketch of a sine graph or a cos graph or a tan graph. Key function, or the key points of this function, are those two. Obviously pi over 2 and 3 pi over 2 are just as important. So the 3 makes the amplitude go up to 3, and the 2 there means my period is halved. So here is my new graph. There's pi, it's 2 pi, pi over 2, 3 pi over 2. Now that is 1 period, so I need to go up 1 period, two waves in that 2 pi period, going up to 3. So when we're trying to solve for 2, we're going to get 4 answers in this 2 pi period. Now the algebra around that, okay, so I'm going to go 3 sine 2x equals 2, so sine of 2x is 2/3, so 2x is the arc sine of 2/3. Push it into your calculator and you should get 0.729 to 3 significant figures. So if you get that, then x is just 0.365. Now, because my period's changed, I'm going to go there, that way. I'm also going to go backwards. Okay, so from my graph, I know that x1 is going to be 0 plus 0.365. x2 is going to be pi over 2 minus 0.365. x3 is pi plus 0.365. and x4 is 3 pi over 2 minus 0.365. That's from my graph. Now those are the only ones that are going to fit in that domain. Now I calculated those earlier, so that should be 0.365 obviously. The next one should be 1.206, 3.507 and 4.347. Okay, so just be careful when you're doing these ones. Look at that as degrees. Okay, so that's not 10 to the power of 0, that is 10 degrees. So that's been shifted to the left 10 degrees. So this is our standard sine graph. That is 360, and that is 180, there's 90, and there's 270. Now that 5 changes the amplitude, and the plus 10 moves everything back to the left, so it wouldn't be able to be this. Instead of going through 90, we'll go through at 80. That'll be at 170, that'll be at 260, and that'll be at 350. And so where are we going here? Like that. We're still talking about this 360 period, so I'm not worried about this area here. Okay, but let's solve it. Up there is 5, down there is -5, and we're looking along here at 3 again. So what we do, 5 cos x plus 10 equals 3, so cos of x plus 10 is 3/5. So x plus 10 is the arc cosine of 3/5, which is 53.1. Just check that on my calculator. Make sure it's in degrees, which mine isn't, so make sure I put it into degrees. The arc cos of 3/5 is 53. Cool. So therefore x is 53.1 minus 10, which is 43.1 degrees. So this one here is 43.1 degrees. Now I need to find out what this one here is. Now from my here to there is 53, so from 350 backwards will be 53 as well. So I'm going to go 350 minus the 53.1, which will be 296.9. Just double check that for one of those sort of moods. Maybe I'll put it into my calculator wrong. Yep, so that was correct. Okay, now if I should probably double check these. If I go 5 cosine 43.1 plus 10, my calculator, I should get 3.0. Yeah, basically 3. The error in the calculator is just because of my rounding to one significant figure, or one decimal place, sorry. And that is the same thing, so there are my two solutions. Back to radians here. This graph is a bit easier to sketch, even though it's a tan graph. It's the normal tan graph, pi over 2 and 3 pi over 2, and there will be my graph. So the 2 just shifts all of these points back. All these points, that's pi, they're all halved. So in other words, my new graph has an asymptote at pi over 4, that'll be pi over 2, the new asymptote will be at, what's that, 3 pi over 4, and that will still be, pi will still go through there. So there's my graph. Now that interval, I haven't drawn my graph, but I know the pattern of it, because now all I need to do is solve this. So tan of 2x is 8 divided by 5, so 2x is the arctan of 8 over 5, which is 1.6. Now that is 1.012, so x is 0.5061. So if I draw my line here at 8, what I'm saying is that one there, 0.5061. Now that is from there outwards, so there outwards, give me that answer, from there outwards, give me that answer. So really my answers x1 will be 0 plus 0.5061, x2 will be pi over 2 plus 0.5061, x3 will be pi plus 0.5061, x4 will be 3 pi over 2 plus 0.5061. Remember, that's that tangent general solution pattern. Now they'll give me some answers of 0.5061. That gives me an answer of 2.077. That is 3.648, and that is 5.218. Okay, so this one here, when I first started, I got a little bit confused with my my formula. I think I had it right, but I had the brackets in the wrong way. So just a little trick there. So when you're doing this one, I think it's easier to talk about just the same unit. So that's 0.2 meters. Okay, if you had a little sketch of that, the height is at 0.2 meters. The max height's at 1.3. So the amplitude has to be basically half of that. So if we go into 1.3 minus the 0.2, that's 1.1. If we then halve 1.1, we get 0.55. That's our amplitude. Okay, now because our amplitude, there's two amplitudes in that distance, and the baseline is actually at 0.75. Our baseline is the bottom point plus one of the amplitudes. So when I'm starting to write my formula, I'm going to have h is going to be 1.1. Right. Start again. 0.55. My amplitude. Sorry, I'm looking up here, getting a little confused with my numbers. 0.55. I'm going to have something in here, and then I'm going to finish off with a plus 0.75. So that's what that tells me. This part in here, the 15 seconds for a complete rotation. Now, I always sort of go back to the formula where the period is 2 pi divided by the frequency. If you have a sine of 2x graph, then the period is 2 pi divided by 2, which is pi. So in this particular case, the period is 15. The period is 15, and we're trying to find that frequency. So in other words, frequency is 2 pi divided by 15. So in here, there's going to be a 2 pi over 15. So this is the part where this is all of it. All of that is over 15. Because the minimum height is 4 seconds afterwards, so I need to shift that bottom point to the right 4 places by doing that. Bottom point, I can just make it a cos graph, and it's a bottom point, so it's negative. So I'll rewrite this properly so you can potentially see it a bit better. So h is negative 0.55, cosine of 2 pi t minus 4 all over 15 plus 0.75. Now, just to reiterate those points, the amplitude is 0.55, and because I'm starting at the low point, that's why it's a negative. It's cos, because I want to start at that low point. It's been shifted over 4 places to the right. The baseline's moved up 7.5, and the period is now 15. So if I was to draw that graph is going to be, there's 0.2, there's 1.3, there's 0.75, here's 4, there's my low point, over here at 19 is my next low point. So I'm going to go up there and down like that, where that point there is halfway between, which is just 11.5. Okay, so let's just translate that formula from the previous page over here. T minus 4 over 15 plus 0.575. Now I'm working in radians here, so my calculator needs to be in radians. So to find B, all we're doing is really saying, well, if T is 15, what is H? Well, so H is just negative 0.55 cos 2 pi into 15 minus 4 divided by 15 plus 0.75. Put that into your calculator and you should get 0.8075, which is 81 centimeters. So 2 significant figures. The next one, give one time when the floor is 0.5 meters above the ground. So this one's a little bit trickier. This one is saying H is 0.5. Let's find T. So I'm just going to go 0.5 in there equals negative 0.55 cosine 2 pi t minus 4 over 15 plus 0.75. What I'm going to do is I'm going to subtract that from here, get negative 0.25 I'm also going to divide by that at the same time, just so I don't have lots of space. Because I don't have lots of space, that equals cos of, I'm just going to not write that bracket out, otherwise this video will take for ages. I need to do the arc cosine, so I'll write that bracket out now. 2 pi t minus 4 over 15 equals the arc cosine of negative 25 over negative 0.55. That gives me an answer of 1.099. So t minus 4 is 1.099 times 15 divided by 2 pi, and t is just 4 added on to that, which gives me an answer of 6.6. Now 6.6 is not the earliest one, but it just says give me one time. Okay. The reason why that's not the earliest time is because of in your general solution, this is the formula for cosine graphs. It just happens that this negative alpha actually is in that period, but it doesn't matter. There's one answer. Hopefully that makes sense. And the last question, we're talking about each revolution stays at least a meter off the ground. So in other words, we've got to do exactly the same thing. So we're going to go, when is h1? So let's find, and this time we have to find 2 t's. Now I'm solving the same formula as I did up here, except that 0.5 is going to become 1. 1 minus, so equals negative 0.55 cosine 2 pi t minus 4 over 15 plus 0.75. Do the same, subtract. I'm going to subtract that and divide by that at the same time, which leaves me with 0.25 over 0.55. That's negative. And that's the cosine of that bracket. So 2 pi t minus 4 over 15 is the arc cosine of 0.25 over negative 0.55. Now that gives me an answer of 2.043. So t minus 4 is 2.043 times 15 over 2 pi, and t happens to be 4 plus that. Put that into my calculator and I'll get 8.876. Okay. Now, just bearing in mind my graph. Okay, just going to draw my graph over here. It doesn't have to be the most accurate graph. All I'm really talking about is from here, which is 4, I'm adding on this part here. So I'll do the same from 19, because my period is 15. I'll subtract that part there from 19. So my my time 2 is 19 minus 2.043 times 15 over 2 pi. That gives me an answer of 14.124. Okay, so if that's 14.124 and that's 8.876, then the time it spends above 1 meter is just the difference between them. It's just the difference between those two numbers, which is 5.248 seconds. Okay, so a lot of working on there, but hopefully that makes sense for you. Okay, so this one's quite a tricky one as well. You've got to find the general solution. So it's not really an identity that you're trying to work with the left-hand side. You're actually trying to solve this whole thing. Okay, so if I write that out again, what I'm trying to do is actually sort of bring that over here to have this equaling 3. So if I go 5 cos squared x minus cos 2x minus sine squared x equals 3, I'm trying to solve that. Okay, so that there is just a complicated graph. Now, let's have a look. Let's try and make it a little bit easier. So cos 2x is the same as cos squared x minus sine squared x. So I'm just going to go 5 cos squared x minus cos squared x minus sine squared x minus sine squared x equals 3. If I expand this bracket, 5 cos squared x minus cos squared x plus sine squared x minus sine squared x is 3. Now, they'll cancel. This will simplify to just be 4. So I'm left with 4 cos squared x equals 3. Now that's a bit easier to do, because I can say that cos squared x is 3/4. Now remember, cos squared x is the same as cos x squared, so think about it that way. So cos x is the square root of 3/4, and so x is now the arc cosine of root 3/4. Do that on your calculator, which I did, and I've just deleted it. So okay, that gives me an answer of 0.5236 to 4 significant figures. Okay, so that's one of my solutions. Now, normally what you'd do is you'd talk about my theta being 2n pi plus or minus this alpha. Okay, this alpha, but it's not, because that's talking about where the graph goes below the axis as well, and this one here is a cos squared, so it doesn't actually dip below the axis. So in other words, the period in a way is actually only pi, and as I've spoken to you guys, this 2 pi is the period of my cosine graph, and because the period actually doesn't go into negatives, then the period's only pi. So the general formula will be theta equals n pi plus or minus alpha. So theta is n pi plus or minus 0.5236. Okay, so this one here stumped me for a while. I didn't have my formula sheet on me, okay, because if I had, it would have told me that denominator is actually sec squared theta. So that is sec squared, okay, well, it's actually sec squared alpha, sorry. So I'm going to break that fraction up into its 2 parts. So that's 1 over sec squared alpha minus tan squared alpha over sec squared alpha. Sec is the same, 1 over sec will be cos squared, so that's going to be cos squared alpha minus tan squared alpha cos squared alpha. Now tan squared alpha is sine over cos, so that's going to be cos squared alpha minus sine squared alpha over cosine squared alpha times cosine squared alpha. Now those ones will cancel, which will leave me with cos squared alpha minus sine squared alpha, which from the double angle formula is the same as 2 cos squared alpha minus 1, which is therefore my right hand side.